So I have a couple of things we could work on, and this will basically be a review of maybe grade 11 math. You may not have done most of these in class, but we have done them. And I don't think they're terribly difficult, and obviously I'm going to help you with them as well. Let's run through these, and then we can do some reciprocal stuff. Starts off with exponents, which is kind of like the rationals unit, but it's very simple. Like, let's look at this. What's the answer to A? I can be your calculator. You can tell me what you want, and I can put it in. We don't really need a calculator for any of these. Actually, it says don't use a calculator, so never mind. How do we do A? So we have -3 to the 4. We can't use a calculator, right?
Mm-hmm.
So what you need to do is you need to make it easier for yourself to do it in your head. Power 4 is a bit too much. Oh, the answer to this is 81. But usually what you do is you want to simplify that power and break it apart. So it's power 2. I'm going to do it power 2 and then power 2 like this. And I'm allowed to do this because 2 plus 2 adds up to 4. This is 9, positive 9. It's in a bracket, so the negative sign also gets squared, becomes positive. 9 times 9, and the answer is 81. So that's how you would do part A. Now, part B is extremely similar. Part B and C are both extremely similar. How is part B different than part A? The only difference there is a bracket. What does that mean? Is the answer to this also 81?
It'll be -81.
It'll be -81 exactly, because that power 4 does not apply to the negative sign, so the negative sign will be outside the whole time. So it'll look like this. So that'll be -81. How about C? Would that be positive 81, -81, or something else?
It would be under 1.
It'll be under 1, so it'll be 1 over positive 81, right?
Mm-hmm.
This is 5 squared. This is 3 over 2 squared, whatever that is. What about F? How do you do F? So whenever the exponent is negative, the first step usually, right, almost always is you want to throw it in the denominator, make the
Mm-hmm.
exponent positive. So it'll be 1 over 16 to the 3/4. What I'm going to do here, because we can't use a calculator, I'm going to distribute the index to the outside. So it'll be the fourth root of 16 and then the entire thing cubed, okay?
Mm-hmm.
You can do this in any order. You could have also done 1 over 16 cubed first and then taken the fourth root. But 16 cubed is, who knows what that is? I think that's 256 times 256. It's a very big number, so you can't do that in your head. So that approach doesn't work here. This is the only way you can do it. So it'll be 1 over 2 cubed, and that's 8. 1 over 8, final answer. Not that difficult. Let's move away from these, because most of these are very simple. It says factor each rational expression. Maybe we'll try doing one or two of these. Or simplify, sorry. The question is simplify. All right, you're given this thing. You're asked to simplify. Basically means clean it up as much as possible. You want to see the least number of x's. Can you simplify this? No,
No.
right? Can you simplify this? No.
No.
What about this guy on top? Can you simplify that expression?
Yes.
Yes, how? You can't pull anything out. Yes, you're right. There is a way to simplify it, but it's not by pulling things out. What's the approach? Recall that that is a quadratic trinomial. So you have to use a very specific thing for to simplify this. You have to man it, right?
Mm-hmm.
Quadratic trinomial. First term, second term, third term means man. And if you have something in this form, how do you simplify this? It's not man because there's only two terms.
Difference of squares.
Exactly. So it's not that difficult. So the top one, it multiplies to -2 and adds to -1. So the numbers must be +2, -2, and +1, right?
Mm-hmm.
So then you get 2x squared minus 2x plus x minus 1. What about the denominator? It's pretty simple. It's a difference of squares. Becomes something like this. Only two more steps. This cancels out with this. Over here, we can pull out 2x from here, 1 from here. So it'll become 2x, x minus 1 plus 1, x minus 1. So the entire thing basically becomes 2x plus 1 times x minus 1. Which means this cancels out with this. So the final answer is x minus 1 over x minus 3. And you're done. What can x not be in this question? There are some restrictions to x. Is there any value that x cannot take?
It can't be 0, so it can't be 3.
Can't be 3, okay. So x can't be 3. Anything else? Or is that it?
That's it.
No, there's more. So when it comes to restrictions, you kind of have to think about how the question started. Because if x were to be +3, look at this one. If x were to be +3, you could never simplify it, right? You'll never get to this point if x were to be
Mm-hmm.
+3 because you'd be dividing by a 0. So x also cannot be +3. So x cannot be +3, -3. There's one more. It has to do with the denominator because the denominator cannot be 0. So what other value of x would make one of these denominators 0? -1/2. Look at this expression here. X cannot be what? -1/2. Because that would give you a 0 in the denominator. So whenever you're simplifying an expression like this, you should always write down the restrictions at the end, okay?
Mm-hmm.
It's not that hard, this question. It's just, you just have to man it. We can move away from this. So this one, it says, rationalize the expression. How do we rationalize something? What does rationalize even mean? It means removing the root, okay? Removing the
Mm-hmm.
radical term. So how do we remove this root? You have to multiply it with something, remember. When you rationalize, you have to multiply with the conjugate. That's it. And then when you do this, usually the root cancels out because it's a difference of squares. So what's the conjugate of the term that we have? It's going to be the same thing in the numerator as well as the denominator. Um, in fact, it's just going to be the exact same thing with a plus sign. Remember, this is how it works. If you have a, the conjugate is a. If you have root a plus root b, something in this form, the conjugate is what? Same thing with the minus sign. Why?
Mm-hmm.
Because we want to do a difference of squares. That's the only way to take out the radical. So what would be the conjugate of this expression? It'll be something like this, right?
Mm-hmm.
Is this hard?
No.
It's just the thing with the minus sign. Then what do we get in the numerator? It'll become a difference of squares expression. So you have a minus b times a plus b. We know that'll be a squared minus b squared. So a is root of 4 plus h. That means a squared would be just 4 plus h. The root cancels out with the squared. Minus, what's b squared?
4.
4. And then you have this term in the denominator. This 4 cancels out with this 4. What about the h? Can we cancel the h?
Yes.
Yes. So the final answer here would be 1 over root of 4 plus h plus 2. Okay? That's it.
Mm-hmm.
So again, not that difficult. Just remember, rationalize means conjugate. Either it's going to be itself or it's going to be the same thing with the sign in the middle flipped. There's only two things for conjugate. What about this one? What will be the conjugate of the denominator?
Root of 5 plus 2.
Yeah. What about the numerator? If it says rationalize the numerator, then what will be the conjugate?
Just itself.
Just itself, yes. We're gonna do something called completing the square. This just came up on this, but where does this come from? So, this is all about quadratics, which is x power 2, right? The x power 2 function. Quadratics, you can write it in three forms. The first is the standard form, the one that we see up there. It's usually in this form, ax squared plus bx plus c equals 0. This is good for using the quadratic formula. The next one is what we call the vertex form. This is good for getting the vertex. It has this, it looks like this. There's a square term in there. What about the third way? Let's just talk about two forms because it's asking us to do the difference of squares. All right, something like this. So our goal for this question, they've given us something in the standard form, and they want us to write it in the vertex form. Completing the square just means write the equation in the vertex form. You need to introduce a whole square term in there somewhere. It's a little bit tricky. So how do you get started with this? By the way, the forms, the quadratic forms, there's one more, but the a value is the one constant between the forms. So whatever the a value is in the beginning, The a value doesn't change. The b and c can change. This c and this c aren't necessarily the same. But a is always going to be exactly the same. So let's look at this question. What's the a value here?
It's 1.
It's 1. So we know in our vertex form, the a value is still going to be 1. Completing the square just means vertex form. It needs to be in this form. It's plus k, not plus c, plus k. All right, so let's get started. So there's a few steps. Step number 1, okay, to complete the square is to take the a value out of only the first two terms, not the c value. You don't want to take the a value out of the c value. Whereas if you were manning it or something, then you would take the a out of the entire thing. But when you're completing the square, you only take it out of the first two terms, the square term and the x term. So over here, the a value is 1, and I'm just going to take it out of the first two terms. So nothing really changes. I'm just dividing by 1. So that's step number 1. Step number 2 is, you see this bracket?
Mm-hmm.
Now this has a new a value and it has a new b value. We're concerned about the b value, and the b is a number that's multiplied with the x. What's the b value here?
It's 1.
It's 1. And this is talking about the bracket, okay? So in the bracket, what you want to do is you want to add and subtract half of b squared. That's a little bit difficult to think about. But this is the procedure to complete a square. You always add and subtract half of b squared. So if b is 1, what would be half of b squared?
1/2.
So it'll be 1 over 2 squared, right? So it'll be 1 over 4, right? Or
Mm-hmm.
if you, it'll be 1 over 4. Or if you want, you can also write it in this form. Plus 1 over 2 squared minus 1 over 2 squared. Now what did I do here? Inside the bracket, I added 1 over 2 squared, and at the same time, I subtracted 1 over 2 squared. Now these things are complements of one another. They cancel each other out because it's the same term with a plus sign and a minus sign. So that essentially just adds up to a 0. So I'm just adding an overall value of 0. But you have to do it this way because this term, if you remember, a whole square term has 3 components to it, right? It has the first term squared, it has the second term squared, and then it has 2 times the first term times the second term. There's 3 terms that come out of this. That's why we need 3 terms inside of this bracket. Right now we have 4. So what we're gonna do is this. And this is how it works every single time. The first 3 terms of the bracket, always nothing else changes outside the bracket. The first 3 terms, they make up the whole square term. So it's always gonna be this squared, so it's gonna be x. The squared comes out. So we're taking the square out. It's always gonna be the first term and the last term and the sign between them. So that's how you get your whole square term. It's made up of the 3 terms inside the bracket. And then there's one more term outside the bracket. What do we do with this? With this term, what we do is that we multiply this with the a value and take it outside of this bracket. So what that means for us is that's negative 1 over 4. So negative 1 over 4 times 1 is still negative 1 over 4. And that's how it comes out of the bracket. You have to multiply it with the a value. So the third step is to take the minus b over 2 squared term out by multiplying with the a value. And now we're almost done. So that times that is negative 1 over 4 plus 1. So it'll be 1 times x plus 1 over 2 squared minus plus 3 over 4. And that's the final answer. So if I asked you, where's the vertex of this quadratic, what would be the answer? Remember, this is your h and k, right? If you compare this and this with this thing here, you have your h and you have your k. So where's your vertex? It's at negative 1 over 2, okay? Again, all I'm doing is I'm
Mm-hmm.
comparing this with this. So it's at negative 1 over 2 and 3 over 4. Cool?
Mm-hmm.
So that's completing the square. It gives you the vertex, which we know, right? Is this quadratic opening up or down?
Down.
It's opening up because the a value is positive. If I asked you, what's the point where the slope is 0, do we know the answer?
It's at the vertex.
Exactly, so we have the answer. So this is the point where the slope is 0, right?
Mm-hmm.
There's an easier way to find that point if we use calculus. Let me just show you. We can find the turning point very easily. So if you don't want to, you don't have to do a difference of squares. I'll show you that the answer we get is going to be exactly the same. Just know that in the vertex form, completing the squared form, it has this form. A is a constant. We know A is 1. So what you do is you let this be y. This entire thing is y. We're looking for the turning point. We're looking for the vertex. To find the vertex, you have to set y prime equal to 0. So what's y prime here? If y is x squared plus x plus 1, what's y prime? The derivative. Remember how to do that?
Is it 2x plus 1?
Yeah, it's 2x plus 1. And then you set this equal to 0 because we want to find where the turning point is. The derivative of the first derivative always gives you the turning point if it exists. So then you have 2x equals negative 1, and then you have x equals negative 1 over 2. So now you know the x value of your vertex. To find the y value of your vertex, you're simply going to plug it back into the equation. So it'll be negative 1 over 2 squared plus 1 over 2 plus 1. So that's 1 over 4 plus 1 minus 2 plus 1 minus 1 over 2. So that's 1.25 minus 0.5. That's a 0.75, which is 3 over 4. So there you go. That's another way you can find the vertex using calculus. It's a little bit easier than doing a difference of squares. So now you know your h and your k. This is your h, this is your k, and you know a value is 1 as it was in the beginning. So you're simply going to plug it into this equation. And you'll see that the answer we get is exactly the same. Doesn't matter if you use calculus or if you use a difference of squares. Cool?
Mm-hmm.
It's always good to have multiple ways to attack a question. Alright, that was not that difficult. Let's move away from that. Okay, here it says solve this equation. You're given a fourth power equation. Any ideas on how to solve this? Is it possible to solve this, or do we graph it? Well, graphing it is always going to give us the answer on Desmos. How do you think we solve this? And I'm telling you, it's not a graphical approach. How would you solve a power 2 equation? Let's say instead of x power 4, this was x power 2.
You would want to factor it?
Using what?
Man?
Man, okay, so this is power 4, but the concept is similar. What we're gonna do is we want to man this, okay? But we have power 4. Man is for power 2. So now what do we do? What we're gonna do is we're gonna introduce a little hack. Let x squared be a. If x squared is a, this becomes 3a, right? What does x4 become? If x squared is a, what's x4 in terms of a?
2A.
Nope. That would be 2x squared. We're looking for x power 4, so it won't be 2a. X squared is a. We want x4. Did we multiply this by 2? No, right? What did we do? How did we go from x squared to x4? How would we go? Let's say you have x4 on one side of the equation, you have x2 on the other side of the equation. What can you do with this to make it x4? It's not multiplied by 2. It's not a multiplication. You have to think
You
about it.
square it.
You square it. So that's the same thing you would do on this side. So what's x4 in terms of a?
A squared.
A squared. And there we go. Now we have a quadratic we can work with, right? It's in the right form. We can man this. Oh, this will be a, this is pretty simple. I'm not going to waste time on this. So it'll be this. So a is 2 and a is 1. Cool?
Mm-hmm.
But we're not looking for a. The question originally started with x, so our final answer should always be in terms of x. So now what we do is we go back here. So x squared was a, also x squared is 2. This is x squared. And then x squared is 1. So that means x is plus minus 1. At this level, the square root of anything is plus minus. And here it would be plus minus square root of 2. Cool?
Mm-hmm.
So it had 4 solutions. So a quick sketch of this. Root 2 is about 1.4. So it has a y-intercept of 2. And we know it's a positive quartic. So it's going to start in quadrant 2. It's going to end in quadrant 1. It's going to go through negative 1, positive 1, 1.14, negative 1.14. So a sketch would look something like this. There we go. Did that make sense?
Mm-hmm.
Here's a question for you, okay? Pop quiz. How would we find these points? Because I drew them there arbitrarily, but it could go anywhere, right? Like, could be like something like this, or the other way around, or it could be very short. So the question is, how do we find those things? So just recall what's happening. How would you classify this point? What's happening at this point?
The slope is 0.
The slope is 0. So all you have to do is set the slope equals 0. So what's the derivative of this function? If this is
It's
y, what's y prime? Yeah, sorry, go ahead.
4x cubed
Yeah? Any
minus 6x.
minus 6x equals 0, exactly. Now how do we factor this? You know? The goal is just to factor this, right? How would you solve this for x? You have to factor it. Ask yourself, is there anything we can pull out?
2x.
It's 2x, so you're left with x squared minus 3. So that means 2x is 0, x is 0, so that's our turning point. One of the turning points is at x equals 0, but we already knew that. That was the y-intercept. If you plug x equals 0 back in here, you'll see that you'll get 2. We knew that turning point. Now the other two turning points, x squared minus 3 equals 0, so it's at plus minus root 3, okay?
Mm-hmm.
So this turning point is at root 3, and that turning point is at root 3. Cool?
Mm-hmm.
And you're done. So that's how you want to solve that question. So although it's not a quadratic, you can man it. Let's start doing a more difficult problem. This one's definitely going to throw you off. What is this function called? Notice the lines on the outside. This is the parent function. What is this function called? Is it the reciprocal function? No, right now.
No.
No. It's the absolute value, okay? Absolute value function.
Mm-hmm.
What does it give you? It always gives you the positive answer. What's the absolute value of -5?
It's 5.
It's 5, exactly. It just gives you the positive number. The parent function looks like a V. Well, in terms of properties and characteristics, it's very similar to quadratic, the absolute value function. Looks like a V. It's just a quadratic, but with straight lines. So this is the absolute value function. If you want to make your life a little bit more complicated, we can go a little bit more deep into this. What it is, the absolute value function. When x is less than 0, to the left of the y-axis, your function is y equals -x. And when x is greater than 0, your function is positive x. So it's just made out of y equals -x, which is this line, but only this part of it, and y equals positive x, this part of it. So it's a combination of this and this. That's how you get this absolute value function. The question is asking us to solve this for x. So let's do it. Well, the first thing is very simple. You divide both sides by 3. There's no question about that. So step number 1 is this, okay?
Mm-hmm.
Now this next step, you have to know this. And it's a little trick that you have to do for absolute value functions. What you do is there's always two components to an absolute value function. One of them is the positive component. It stems from the fact that it's made up of positive x and negative x. The same function,
Mm-hmm.
but reflected on, not necessarily reflected on any axis. The mirror image, right? I guess you could say it's reflected on the y-axis. Reflected on the y-axis. So it's made up of two components. One of them is always going to be positive. One of them is always going to be negative. So what you do is you take this number as is, okay?
Mm-hmm.
On one side, it'll be negative x minus whatever's in that absolute value thing. Negative x minus 4. And on the other side, it'll be positive x minus 4, like this. And then you solve these equations for x. So over here, it'll be 10 over 3 plus 4. So that's 12, 22 over 3. That's about 7. On the other side, it's x minus 4 equals negative 10 over 3. So it's x equals negative 10 over 3 plus 12 over 3. So that's 2 over 3. That's about 0.67. So those are the two solutions to this. Cool?
Mm-hmm.
So in an absolute value equation, to solve it, leave the right-hand side as is, but the left-hand side, you want to make it into negative bracket that equation, positive bracket that equation, okay?
Mm-hmm.
Now let's do a janky problem. What is the function here? What do you think the function is? Is it linear?
No.
No, it's not. What is it then? It's a root function, okay? It's a root
Mm-hmm.
function, but this one will go in the denominator, so I guess you could get away with calling this a rational function. So this is what it is. We want to solve for x, okay? So one of them is a fraction, the other one is not. How do we combine a fraction and a non-fraction? I want one term. Right now I have two terms. You take the LCD, okay? You take the
Mm-hmm.
lowest common denominator. What is the LCD here? It's root 4 minus x. This is the denominator. So that's going to be our LCD. So we're going to leave the first term as is. But the second term, we're going to multiply this with root 4 minus x on the bottom and root 4 minus x on the top. So that means we get a combined 4 minus x on the bottom. This one, 2x, didn't touch it. What do I get after the minus sign? What is the right-hand side? Sorry, what does this expression simplify to?
It's just 3 times 4 minus x.
Yeah, so it'll be negative 12 minus 3x or plus 3x?
Minus?
Minus, plus. Negative 3 times, so it's negative 3 times 4 minus x. So it'll be negative 12 plus 3x equal to
Mm-hmm.
0. Can we multiply both sides by the denominator to get rid of the denominator?
Yes.
Yes. So you get 5x minus 12 equals 0. X is 12 over 5. So we solve this complicated looking thing in 3 steps, right? Not that difficult. Cool?
Mm-hmm.
So this is just algebra, right? Just dealing with radicals. Let's talk about reciprocals. So you have kind of an understanding for your classes. So a reciprocal function is 1 over something, okay? 1 over any other function. That is a reciprocal function. On the other hand, if you have f of x and maybe another function here, g of x, this we call a rational function. It's a little bit more annoying to deal with. This one is a reciprocal function, just 1 on the numerator, solid 1, or any number. No letters allowed, because if you have an x on the top, that means you have two different functions. So let's talk about this one. Let's start with a very easy one. Let's start with this one. Start with y equals x plus 2. What is the reciprocal of x plus 2?
1 over x plus 2.
So we can call this y1, let's call this y2 is equals to 1 over x plus 2. What we're gonna do is we're gonna talk about the properties of these two functions. And we're gonna do them, where would this be? Let me just see if I can figure out where reciprocal functions is going to be. It's chapter 2 or 3. It's not chapter 4. There's a nice little table that we can create for reciprocal functions. Let me see if I can find out where it is. Hopefully I can find it. If not, I know what the table should look like. I can't seem to find it right now, but it's not a very big deal. So let's graph these two things. I'm gonna be a little bit precise here. I'm gonna graph them on the same plane. So how do we graph x plus 2? This function. Where's the y-intercept?
2.
2. What's the slope?
1.
1, right? So it goes up by 1 unit, goes across by 1 unit. So your x plus 2, very easy to graph, looks like, I mean, it's just a straight line. Let me just zoom into this. And it goes like this in both directions. Very simple. Now, the reciprocal function, 1 over x plus 2. Now, you want to think about it this way. It's the same function as x plus 2, okay? The function is well, it's the same function. The x values, if this writes, the x values stay the same. But the y values, all the y values, they become 1 over y. So here's what I mean, okay? You see this point is 2 on the parent function, on the linear function. In the reciprocal function, that point is gonna flip upside down. So 2, okay, if you want to make a table of values here, so you have x, you have y, and then you have 1 over y. This is x plus 2, and this is 1 over x plus 2. At the x value of 0, the y value for this is 2. What's going to be the y value for our reciprocal function? It's the same thing flipped upside down, okay?
So 1 over 2.
1 over 2. So that's going to be our first point. At 0, we have 0.5. Is there any x value that this cannot take? Was there any value of x that would make the denominator a 0?
-2.
-2. So if x were to be -2, your denominator would be 0. So in reciprocal functions, we have two types of asymptotes. We have the vertical asymptote. It's called VA. And this is when the denominator equal to 0. So in this case, our vertical asymptote is going to be x equals -2. Because if x were to be -2, our function wouldn't exist. So -1, -2. We're going to get a hard wall at this point, right? And there's another asymptote for reciprocal function. It's the horizontal asymptote. And without question, if your numerator is 1, okay? If your numerator is 1 or any number, doesn't matter. That doesn't have an x, that's the only requirement. Your horizontal asymptote will always be at y equals 0. For a reciprocal function, the horizontal asymptote is always going to be the x-axis. Okay?
Mm-hmm.
Now what we're going to do, all we're going to do is we're going to flip these points to get a general idea of what our curve looks like. Just going to flip them upside down. So this point is 3, right? At x1, y is 3, it's going to become 1 over 3. So it's going to become 0. It's going to become even smaller. This was 0.5, this is 0.33. And if you keep going, that point is going to become even smaller, smaller, smaller. So the trend is going to look like this. What about this value right here? The y value there is 1. So when x is -1, the y value is exactly 1 for the main function. What would be the y value for the reciprocal function? Would it change? No, right? Because if you do 1
Mm-hmm.
over 1, you're still going to get a 1. So this point is a constant. And then you keep going. Over here, the y value is 0.5. So that means for the reciprocal function, again, I don't know what the x value is, but I know the y value there is 0.5. That means for the reciprocal function, it's going to be 2, 1 over 0.5. So this point is going to jump up here. And you can see the general pattern like that. Now the exact same thing is going to happen on the left side of the asymptote. This point, the y value is -1. What's the y value of the reciprocal? If you flip it upside down, what's -1? Does it change? No, right?
No.
So that point stays exactly where it is. Over here, the y value is 0.5. What's the y value for the reciprocal function? It's -0.5, sorry, -0.5. The reciprocal, it would be 1 over -0.5. It would become 2. So this point comes 1 right here at 2, okay? And you can
Mhm.
see the general pattern. It'll look like this if you plugged more points in. So that is the reciprocal function of 1 over x plus 2. Let's see what we noticed. Let's talk about the properties. So for the reciprocal function, how do we get the y-intercept? How do we get this point? You take the y-intercept of your function, right?
Mhm.
Like here, it's x plus 2. We know the y-intercept is 2 just from the equation itself. You just flip it upside down. So like that, 1 over y-intercept of y1. But I think more important things are these. Um, we're going to call these positive intervals and negative intervals. So that means one is the y value positive, one is the y value negative. So let's talk about it for the main function, x plus 2, the linear function. When is that positive? When are the y values of that equation positive? So it's positive right here. You see here? That's the y
Mhm.
value 0, so it's positive to the right of this point. So that point is x equals -2. That was the asymptote, right? So that
Mhm.
means positive interval is when x is greater than -2. For the main function, what about the reciprocal function? Did that change? Is it different or is it the same? Where it's positive, and if you look at the graph, you'll see that it's exactly the same. The reciprocal function, that is also positive to the right of the asymptote. And the exact same thing is going to happen for the negative intervals. The linear function is negative to the left of the interval. The reciprocal function is negative to the left of the interval. So what does this mean? Positive and negative intervals are the same. Are
Mhm.
same for reciprocal and its parent function. So that is unchanged. If you have one, you have the other. Okay?
Okay.
That's pretty straightforward. Now, a little bit more complicated is increasing and decreasing intervals. So you know what the function is. Let's talk about increasing and decreasing. So let's focus on y. When is y increasing? When is it decreasing? We're talking about x plus 2, the linear function. When is this function increasing? When is the slope positive? Increasing just means when is the slope positive?
It always is.
It always is. So it's always increasing. XCR. Is it decreasing anywhere else? No, right?
No.
It's not decreasing anywhere. Now let's talk about the reciprocal function. Where is this increasing, if anywhere? Is the reciprocal function increasing anywhere from the sketch? No, right? If you look at
Mm-hmm.
the tangent, the slope of the tangent line, you'll see that it's always going down everywhere. Like there, it's going down, there, it's going down, there, it's going down. Even on this side, it's going down, it's going down, it's going down. So it's increasing nowhere. What about decreasing? Where is it decreasing? Everywhere except the asymptote, okay?
Mm-hmm.
It's decreasing everywhere, and it just can't be the -2 value. So what do we notice about increasing and decreasing intervals for parent function and the reciprocal function? They're the opposite. Look at this one. Decreasing here becomes increasing here, and increasing here becomes decreasing here, and obviously the restriction if there is any. So they're the opposite. Increasing and decreasing intervals are the opposite. Positive and negative intervals are the same. Cool?
Mm-hmm.
Okay, quickly we're gonna graph y equals x minus 2 and y equals 1 over x plus 2. We're not gonna be super precise. This minus 2, does it shift it to the right or left?
The right.
The right. So yeah, usually it'll look like this. Not a straight line, but like usually it would look like this, but now it's gonna be the same thing except it's pushed 2 units to the right. So when x is 2, y is 0. When x is 6, 3, 4, 5, 6, y is 2. So I'm just making a rough sketch of this guy. So it looks like this. So we're going to graph 1 over x plus 2. Okay. Is there any
Mm-hmm.
value x cannot be? That's always going to be the first thing. And that's going to give us our vertical asymptote, if there are any.
It can't be -2.
It can't be -2. So there's our vertical asymptote. Um, all right. So now all you have to do is flip the points. What's the y value here? I messed this one up. This should have been x plus x minus 2. So the asymptote would have been at +2. Okay, like that. So the y value here is 0. 1 over 0 is undefined. That's why there's an asymptote. The y value here is about 0.5, right?
Mm-hmm.
So for the flipped function, it's going to be about 2. What about here? The y value here is 2 for the main function. What would it be for the reciprocal function? 0.5, right? 2 becomes 1 over 2, which is 0.5. So this point comes down here. So a sketch of this, our very rough sketch, we know there's an asymptote on the x-axis. Would look something like this. Cool?
Mm-hmm.
So that's how you do reciprocal functions. It's not that difficult, especially if you know the properties of the main function, like how we did. We know -2 would shift it to the right. We know we can't have negative numbers inside a root. Then graphing the reciprocals is not that difficult. All right, let's call it there for today.
Okay, thank you.
See ya.